For this lab, we cut out identical pieces of wood for our glued and non-glued beam on the table saw by setting the guard to exactly 2 inches, and we measured to confirm. And they were all 20 inches long off of the same piece of wood, and they're all 0.2 inches thick, which we measured with calipers. And then to apply the weight in our experiment, we used this little weight carrier that the weights come on, and it weighed in at 0.25 pounds. And then the 100-gram weights each weighed in at 0.22 pounds. And then we also made a beam out of acrylic that was 3 inches wide, but this beam was more just to be used in the polariscope and to see the slippage in between the layers. And then to set up the experiment was a lot of trouble, and we made sure to exactly set the tables 18 inches apart to have 1 inch of overlap of our beam on each side. And the hardest part was getting the deflection measure to be exact and not move during the experiment, which is why in the picture you see the wood board that it's attached to weighted down, and we also clamped the device to the board to ensure that it didn't move. And we also marked the center of our wood beams and the center of our weight carrier so that we could ensure the weight was loaded in the exact center.
So this is our beam bending lab presentation. So our setup right here, we have our gauge that measures deflection. The board that's set in there right now, this is the one that is not connected, so the individual members are allowed to slide. That is our mark right here of the center of the beam where our weights will be going. We'll do 3 experiments, 3 different weights for each 2 beams. This one where it's glued together so it acts as a single beam, and they will each be weighted with 3 different weights. This one is 0.88 pounds, and then we will add 0.66 pounds for each experiment. So, first one, right here, it does appear to be zeroed. Right there, get the gauge zeroed. Right about there, okay. And that has deflected from 0 all the way to there, you can see, and then adding our 0.66 pounds. Almost 1 full rotation. And then our other 0.66 pounds. Rotation right there. And that is for the beam without the glue. So with the glue, we will get it zeroed here. That's pretty close to 0. 0.88 pounds. You can see it has deflected much less than the beam without the glue. Adding 0.66 pounds. Deflected hardly at all. And then another 0.66 pounds. And that is a total deflection straight from 0 to where the dial is now. The other one did over a full rotation.
So after testing, we decided to put the data into Excel. We did 3 separate tests per 2 specimens. So we had a total of 6 tests. We used the same weight on all tests. For test 1, we used 1.125 pounds. Test 2, we used 1.75 pounds. And test 3, we used 2.375 pounds. So for deflection, on the glued wood, we got 0.01 inches of deflection on the first test. On the second test, we gained 0.005 inches, so we got a 0.015 inches. And then the same thing for test 3, we gained another 0.005 inches, and it ends up being 0.02 inches. For the non-glued wood deflection, we got 0.06 inches, second test 0.09 inches, and third test 0.12 inches. And as you can see, it's linear. So what we can gather from this is that the non-glued wood deflected 6 times more on all 3 tests than the glued wood. And as you can see, we put the data into a scatter plot on Excel, and the steeper the slope in this, the more rigid the material is. As you can see, deflection's in our x-axis, and weight is in our y-axis. And as you can see, the blue is glued wood, and the orange is non-glued wood.
So in conclusion, we conducted 6 different experiments with 2 different beams and 3 different weights for each beam. We found that the beam that was glued together was 6 times more rigid than the beam with the members that were allowed to slide. And we plotted our data into an Excel sheet, and it showed a linear relationship with how much the beams would deflect versus how much weight you put on. We plotted those into an Excel graph, and it showed the linear relationship, as well as the beam with the beam that was glued has a much steeper slope than the beam that was not glued, which shows much greater stiffness. And that is our lab. Thank you all so much for watching.